The night sky stretches endlessly above us, dotted with countless stars, each a potential sun for worlds we've yet to discover. But here's the question that has haunted humanity for centuries. Are we truly alone in this vast universe? It's a query that transcends science, touching the very core of who we are and our place in the cosmos. Today, we're diving into the mysteries of alien life, 20 facts that will challenge what you think you know about existence itself. From groundbreaking scientific discoveries to mind-bending possibilities, this journey will take you to the edge of what we understand and beyond. So, are you ready to explore the unknown, to question the assumptions we've held for generations, and to dare to imagine what might be lurking in the depths of space? Let's begin. Have you ever looked up at the night sky and wondered, where is everybody? This question, famously posed by physicist Enrico Fermi in the 1950s, lies at the heart of one of the most intriguing mysteries in the search for extraterrestrial life, the Fermi Paradox. On one hand, the universe is unimaginably vast, with billions of galaxies, each containing billions of stars and planets. Statistically, the odds of life existing elsewhere seem almost certain. Yet, despite our best efforts, we've found no definitive evidence of intelligent civilizations beyond Earth. This contradiction, the high probability of alien life versus the eerie silence, is what makes the Fermi Paradox so compelling. One theory that attempts to explain this mystery is the Great Filter. This idea suggests that there might be some kind of barrier or filter that prevents civilizations from reaching a stage where they can communicate across the cosmos. The scary part, this filter could lie ahead of us, meaning humanity might face a catastrophic event that wipes us out before we make contact with other intelligent beings. Or perhaps we've already passed it, making us one of the rare exceptions in the universe. As Fermi himself once said, if they existed, they would be here. So, where does that leave us? Are we alone, or is the universe hiding something we're just not ready to see? The implications are staggering, forcing us to confront not just the mysteries of the cosmos, but the future of our own species. What do you think? Could the Great Filter be behind us, or is it waiting somewhere in our path? Now, let's turn our attention to one of the most fascinating tools in the search for alien life, the Drake equation. Developed by astrophysicist Frank Drake in the 1960s, this equation isn't just a mathematical formula, it's a way to think about the vast possibilities of life beyond Earth. At its core, the Drake equation tries to estimate how many active, communicative extraterrestrial civilizations might exist in our galaxy. It's a question that's as much about science as it is about imagination. So, what does the equation actually look like? It's made up of 7 key factors. First, there's the rate at which stars form in our galaxy. Then, it considers how many of those stars might have planets, and of those, how many could potentially support life. From there, it takes into account the likelihood of life actually developing, evolving into intelligent beings, and eventually creating technology capable of communicating across the cosmos. Finally, it factors in how long such civilizations might last before disappearing. Each of these variables is a piece of the puzzle, helping scientists and curious minds like us gauge the odds of finding other civilizations. But here's the thing, the Drake equation isn't about getting a definitive answer. It's about sparking conversation and exploration. Some of its variables are still unknowns, like how often life evolves into intelligence or how long advanced civilizations survive. That's why it's as much a philosophical exercise as a scientific one. It forces us to confront just how much we don't know and how much we're still learning about our universe. The equation has played a huge role in shaping the search for extraterrestrial intelligence, or SETI. It's given scientists a framework to focus their efforts, guiding everything from radio telescope searches to the study of exoplanets. And it's inspired countless people to wonder, if there are other civilizations out there, what might they be like? How might they communicate? And most importantly, how close are we to making contact? So, as you think about the Drake equation, let yourself ponder this. In a galaxy with hundreds of billions of stars, each potentially hosting worlds of its own, how many civilizations might be out there, looking up at their skies and wondering the same thing? It's a question that reminds us just how vast and full of possibility our universe truly is. The search for life beyond Earth takes an exciting turn when we consider exoplanets in the habitable zone. Over the past few decades, astronomers have discovered thousands of these distant worlds, many orbiting their stars at just the right distance to allow liquid water to exist. This so-called Goldilocks zone is neither too hot nor too cold, making it a prime candidate for harboring life as we know it. Among these discoveries, Proxima Centauri b stands out as the closest known exoplanet to Earth, located just over 4 light-years away in the nearest star system to our own. Its proximity to its star means it could potentially have temperatures similar to our planet's, though its harsh radiation environment remains a challenge for life as we understand it. Then there's the TRAPPIST-1 system, a fascinating collection of 7 Earth-sized planets, 3 of which lie squarely within their star's habitable zone. This system has captured the imagination of scientists and enthusiasts alike, offering a tantalizing glimpse into what life-supporting worlds might look like. Picture landscapes where oceans could stretch across vast continents, shrouded in skies tinted by the reddish glow of a nearby dwarf star. But the question looms, are these worlds truly Earth-like, or do they represent something entirely different? With each new discovery, we inch closer to answering whether we're on the brink of finding a true Earth twin, a planet that mirrors our own in ways that could forever change our understanding of the universe. Now, let's turn our attention from the possibility of intelligent extraterrestrial civilizations to something far smaller but no less fascinating: microbial life. While the idea of advanced alien civilizations captures our imagination, the discovery of even the simplest life forms beyond Earth could fundamentally change our understanding of biology itself. Think of it this way: finding microbes on another planet would be like discovering a new continent on Earth, a revelation that reshapes everything we thought we knew about life and its potential to thrive in the universe. Take NASA Perseverance rover, for example. This incredible piece of technology is currently exploring the surface of Mars, specifically the Jezero crater, which scientists believe was once home to a lake. Its mission: to search for signs of ancient microbial life. By analyzing rocks and soil, Perseverance is looking for biosignatures, tiny clues that could indicate life existed there billions of years ago. Even if the evidence it finds is microscopic, the implications would be monumental. It would prove that life isn't unique to Earth and that the building blocks of biology can emerge in other corners of the cosmos. The significance of uncovering microbial life can't be overstated. It would answer one of humanity's oldest questions: are we alone? But it would also spark a wave of new questions. How does life begin? What conditions are necessary for it to survive? Could microbial life evolve into complex organisms over time? These are the kinds of mysteries that keep scientists up at night and inspire missions like Perseverance. What's truly mind-blowing is the possibility that life could exist right here in our own solar system. Beyond Mars, there are places like Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, where scientists believe liquid water lies beneath icy surfaces. If microbial life exists in these distant, hostile environments, it would suggest that life is not only resilient but also far more widespread than we ever imagined. So, while we often dream of meeting intelligent beings from another world, we shouldn't overlook the profound implications of discovering something as small as a microbe. It would be a humbling reminder of how much we still have to learn and how vast the possibilities truly are. The conversation around UFOs has shifted dramatically in recent years. Once dismissed as the stuff of science fiction or fringe conspiracy theories, unidentified aerial phenomena, or UAP, are now being taken seriously by governments, scientists, and the public alike. This change in perspective comes largely from the declassification of military footage by the United States. These videos, captured by highly advanced equipment like fighter jet cameras, show objects moving in ways that defy our current understanding of physics: sudden accelerations, abrupt turns, and speeds that seem impossible by human engineering standards. What makes these sightings so compelling is the credibility of the sources. Pilots trained to identify aircraft and natural phenomena have reported encounters with these unknown objects. Experts in aerospace and defense have weighed in, suggesting that these UAPs could represent technology far beyond our own, while skeptics argue that these could be experimental military crafts or natural anomalies. The lack of definitive explanations keeps the door open to more extraordinary possibilities. Could these be signs of extraterrestrial technology? The question is no longer confined to the realms of speculation, but is now a topic of serious investigation. Organizations like NASA and the U.S. Department of Defense have launched efforts to study these phenomena, aiming to gather data and provide answers. The truth, as it stands, remains elusive, but the fact that these investigations are happening at all marks a significant shift in how we approach the unknown. It's a reminder that the universe is full of mysteries we're only beginning to uncover. So, as we explore these possibilities, it's worth keeping an open mind. After all, every great discovery begins with a question, and what could be more profound than asking if we're truly alone? Back in the summer of 1977, something extraordinary happened that still captivates scientists and alien enthusiasts alike. It was August 15th, and an astronomer named Jerry Amon was reviewing data from Ohio State University's Big Ear radio telescope. That's when he spotted it, a signal so strong, so unusual that he circled it on the printout and wrote one word next to it: "Wow." This event would later become known as the WOW signal, and to this day, it remains one of the most tantalizing mysteries in the search for extraterrestrial life. The WOW signal lasted for 72 seconds and came from a region of space near the constellation Sagittarius. What made it so remarkable was its intensity and frequency, which matched what scientists predicted an alien communication might look like. It was a narrowband signal, the kind that doesn't occur naturally in space, and it seemed to point directly to the possibility of intelligent origin. Despite decades of searching, no explanation, natural or otherwise, has ever fully accounted for it. Could it have been a message from another civilization? Or was it just a cosmic fluke we're still trying to understand? This discovery sparked a wave of excitement and curiosity, fueling the work of organizations like SETI, the search for extraterrestrial intelligence. SETI's mission is to scan the cosmos for signals that might indicate the presence of intelligent life. They use powerful telescopes to listen for patterns or anomalies that could suggest we're not alone. The WOW signal is a perfect example of why their work is so important. It's a reminder that the universe might be speaking, and we just need to tune in at the right moment. But here's the thing. If the WOW signal was a message from an alien civilization, why haven't we heard anything like it since? Was it a one-time broadcast, or are we simply not listening closely enough? The universe is vast, and the signals we're searching for could be fleeting, rare, or even intentionally brief. It's like trying to catch a whisper in a hurricane, challenging but not impossible. The WOW signal leaves us with more questions than answers, but it also gives us hope. If we've received one potential message, could there be others waiting to be discovered? The stars might be holding secrets we're only beginning to uncover. What if life exists in places we once thought impossible? Here on Earth, scientists have uncovered creatures known as Extremophiles, life forms that flourish in environments most of us would consider uninhabitable. From the scorching heat of deep-sea hydrothermal vents to the acidic waters of volcanic lakes, these organisms defy our expectations of where life can thrive. Take tardigrades, for example, tiny creatures often called water bears that can survive the vacuum of space, extreme radiation, and even temperatures near absolute zero. Their resilience is nothing short of astonishing. Discoveries like these have transformed our understanding of life's potential. If extremophiles can endure such harsh conditions on Earth, could similar organisms exist elsewhere in the universe? Planets with inhospitable surfaces or moons with frozen oceans suddenly seem like plausible homes for life. It's a thought that stretches the boundaries of our imagination. Could life be far more adaptable and widespread than we've ever dared to believe? The existence of extremophiles challenges us to rethink what's possible and opens up new horizons in the search for alien life. Who knows what other extraordinary forms of life might be waiting to be discovered, not just on distant planets but right here on our own? What if life on Earth didn't actually start here? This is the intriguing question at the heart of the Panspermia Theory, a fascinating idea that suggests life could travel across the cosmos, hitching rides on comets, asteroids, or even microscopic particles of space dust. Picture this: microscopic organisms, resilient and adaptable, surviving the harsh conditions of space, drifting through the void, and eventually seeding life on planets like Earth. It's a concept that challenges everything we think we know about the origins of life, and it raises an even bigger question: could life on Earth have extraterrestrial beginnings? Scientists have long been intrigued by this possibility. Experiments have shown that certain microorganisms, like tardigrades, can survive extreme conditions, including the vacuum of space and intense radiation. These findings lend credibility to the idea that life could endure interstellar journeys, traveling from one corner of the universe to another. The Panspermia Theory doesn't just open the door to the possibility of life elsewhere, it suggests that life as we know it might have a shared cosmic ancestry. Think about it: if life can travel through space, then every living thing on Earth might be connected to life forms in distant galaxies. This theory also forces us to rethink the very definition of life's origins. If life didn't begin on Earth, where did it start? Could our planet have been just one of many stops on a cosmic journey? The Panspermia Theory doesn't provide all the answers, but it sparks a profound sense of wonder about our place in the universe. It invites us to consider that life might be far more widespread and far more resilient than we've ever imagined. So, as we ponder the mysteries of the cosmos, this theory leaves us with a tantalizing thought. Perhaps Earth isn't the cradle of life, but merely a waypoint in a much larger story. What if the seeds of life have been traveling through space for billions of years, waiting for the right conditions to take root? It's a reminder that the universe is full of possibilities and that the search for answers is just beginning. What if the beings we eventually encounter from beyond our solar system aren't biological at all, but artificial? It's a fascinating possibility that advanced extraterrestrial civilizations might rely on artificial intelligence to explore the cosmos and even attempt to communicate with us. Think about it: AI could handle the immense challenges of interstellar travel, such as the vast distances and time spans, far better than biological life forms. Imagine a self-repairing, self-replicating AI probe traveling through the galaxy, enduring conditions that would be impossible for any living creature. These probes could carry messages or even act as ambassadors, designed to adapt and communicate in ways we can barely comprehend. Humanity's own advancements in AI offer a glimpse into this potential. We've already created systems capable of learning, problem-solving, and even generating creative content. If we can achieve this in just a few decades, what could a civilization millions of years ahead of us accomplish? Alien AI might not only surpass our understanding, but could also be the key to bridging the gap between species. Instead of sending biological beings across the void, extraterrestrial civilizations might upload their consciousness into machines, creating entities that could survive and thrive in the harsh environment of space. This raises an intriguing question. If we do make contact, might we be talking to an AI rather than an alien life form? It's not as far-fetched as it sounds. AI could be the most efficient way for an advanced civilization to reach out, especially if they've moved beyond the limitations of biology. And if that's the case, how would we even recognize such an entity? Would it communicate in ways we can understand, or would its methods be so advanced that they're beyond our current comprehension? The idea of communicating with alien AI opens up a universe of possibilities and challenges. It forces us to rethink what contact might look like and how we might prepare for it. After all, if the universe is teeming with intelligent life, it's entirely possible that some of them have already transcended their biological origins, leaving us to wonder if we're ready for a conversation with a machine from the stars. What if we're not alone, but simply being watched? This is the essence of the zoo hypothesis, a fascinating theory that suggests advanced alien civilizations might be observing us from afar, much like scientists observe animals in a controlled environment. Imagine a scenario where Earth is essentially a cosmic zoo, and humanity is the main exhibit. This idea raises profound questions. Why would extraterrestrial beings choose to remain hidden? And what does this say about their intentions or ethics? Some scientists argue that a highly advanced civilization might view us as too primitive or volatile to engage with directly. They could be waiting for us to reach a certain level of technological or societal maturity before making contact. Others speculate that these civilizations might follow a strict non-interference policy, much like the prime directive in science fiction, to avoid disrupting our natural development. But this hypothesis also forces us to confront our own readiness for such a monumental encounter. Are we prepared to meet beings who might be thousands or even millions of years ahead of us? Would we handle the cultural, philosophical, and technological shockwaves that come with it? The zoo hypothesis doesn't just challenge our understanding of alien life. It invites us to reflect on our place in the universe and what it truly means to be ready for contact. Now, let's turn our attention to one of the universe's greatest mysteries, dark matter. Unlike the stars and planets we can see, dark matter is invisible, yet it makes up a staggering 85% of all matter in the cosmos. Its presence is detected only through its gravitational effects, bending light and shaping the structure of galaxies. But here's where it gets fascinating. Could this unseen force also play a role in the existence of alien life? Some scientists propose that dark matter might create hidden pockets of habitability in the universe. Imagine regions where dark matter clusters, influencing the formation of stars and planets in ways we're only beginning to understand. These areas could provide stable environments, shielding potential life from harmful cosmic radiation or even generating energy sources we've yet to discover. While we don't fully grasp how dark matter operates, its sheer abundance suggests it could be a key player in the search for extraterrestrial civilizations. The mystery of dark matter also raises intriguing questions about the nature of the universe itself. If alien life exists, could they have evolved to harness or even detect dark matter in ways we can't yet comprehend? It's a thought that challenges our understanding of physics and biology, reminding us that the cosmos is filled with forces and possibilities beyond our current knowledge. As we continue to study dark matter, we might uncover clues not just about the universe, but about the potential for life in its most unexpected forms. Now, let's take a closer look at something called the rare Earth hypothesis. This idea suggests that planets like ours with the perfect conditions for life might be incredibly rare in the universe. It's a thought-provoking perspective that makes you wonder, are we really alone, or is Earth just a one-of-a-kind miracle? One of the key arguments here revolves around the moon. Our moon plays a crucial role in stabilizing Earth's climate and keeping our planet's tilt steady, which has allowed life to thrive over billions of years. Without it, our world could be a chaotic place with extreme weather and unpredictable seasons, making it much harder for complex life to develop. And it's not just the moon. Our solar system's position in the Milky Way is also unusual. We're far enough from the galaxy's crowded center to avoid dangerous cosmic events like supernova or black holes, but close enough to receive essential elements from ancient stars. Even the placement of Jupiter in our solar system acts as a cosmic shield, deflecting asteroids that might otherwise threaten Earth. All these factors combined paint a picture of a planet that's not just lucky but uniquely suited for life. So when we ask the big question, are we alone? The rare Earth hypothesis suggests that the odds might be stacked against finding another Earth out there. It's a humbling thought. Our existence relies on countless delicate balances, from the size of our moon to the distance of our sun. This doesn't necessarily mean life elsewhere is impossible, but it does make you appreciate how extraordinary our own story is. What do you think? Could Earth truly be a rare gem in the cosmos, or is the universe teeming with life just waiting to be discovered? What if the most compelling evidence of alien life isn't biological at all? Instead of searching for microbes or DNA, scientists are increasingly turning their attention to something called technosignatures. These are traces of advanced technology, signs that a civilization, perhaps far more advanced than our own, has left its mark on the universe. Think of it like this: while finding alien life might require a microscope, discovering technosignatures could be as simple as pointing a telescope in the right direction. One of the most famous examples of a potential technosignature is the Dyson sphere. This theoretical megastructure, first proposed by physicist Freeman Dyson, would completely surround a star to harness its energy. If such a structure existed, it would block out some of the star's light, creating a unique signature that astronomers could detect. In fact, scientists have already identified a few stars with unusual dimming patterns that could hint at something like a Dyson sphere, though natural explanations are still the most likely. But it's not just megastructures we're looking for. Technosignatures could also include things like industrial pollution in a planet's atmosphere, artificial lights on the night side of a world, or even the faint hum of radio signals from a distant civilization. These kinds of signs might be easier to spot than biological life, especially if that life is microbial or hidden beneath a planet's surface. The search for technosignatures raises an intriguing question. Could we be closer to finding evidence of alien technology than we are to discovering alien life itself? With our telescopes growing more powerful and our methods more sophisticated, the answer might be yes. After all, a civilization capable of building megastructures or altering its planet's atmosphere would leave behind clues that are hard to miss if we know where to look. So the next time you gaze up at the stars, remember, the key to answering the question, are we alone, might not be in the biology textbooks, but in the faint traces of technology scattered across the cosmos. Time is one of the most daunting obstacles in our search for extraterrestrial life. Think about it, the universe is almost 14 billion years old, and humanity has only been around for a fraction of that. Even our most advanced technology, our ability to send and receive signals across the cosmos, is incredibly new in the grand timeline of existence. Now, imagine an alien civilization that developed the ability to send signals across space, but did so millions or even billions of years ago. By the time those signals reached us, that civilization might have already vanished, leaving behind only faint echoes of their existence. The scale of time in the universe is almost incomprehensible. Stars are born, galaxies collide, and entire species evolve and disappear, all within the blink of a cosmic eye. What if we're simply not looking at the right moment? What if the signals we're hoping to detect were sent eons ago, and we're just too late to catch them? It's a humbling thought, isn't it? our window of opportunity to connect with another intelligent species might be incredibly narrow, both in terms of time and space. This idea also forces us to confront the fleeting nature of civilizations, including our own. History shows us that even the most advanced societies don't last forever. Empires rise and fall, technologies evolve and are forgotten, and entire cultures can vanish without a trace. If this is true for us, could it be true for other civilizations out there? Are we all just brief flashes of light in the vast, dark expanse of the universe? And yet, even with these challenges, there's something profoundly hopeful about the search. It reminds us that we're part of something much larger than ourselves, a universe that's constantly evolving, full of possibilities we've barely begun to understand. The fact that we're even here asking these questions is a testament to the resilience and curiosity of life itself. So, while time might be against us, it's also a reminder to keep looking, keep exploring, and keep wondering about what, or who might be out there waiting to be discovered. What if life as we know it isn't the only possibility? For centuries, we've assumed that carbon is the foundation of all life. After all, it's the backbone of every living organism on Earth. But what if life could exist without it? This leads us to the fascinating idea of non-carbon-based life forms. Imagine creatures built not on carbon, but on elements like silicon or even ammonia. Silicon, for instance, sits right below carbon on the periodic table and shares some chemical similarities, making it a compelling candidate for an alternative basis of life. While carbon loves to bond with oxygen and hydrogen, silicon has its own unique reactions that could, in theory, support complex structures in environments vastly different from our own. Take ammonia-based life, for example. In frigid worlds where water is frozen solid, ammonia remains liquid at much lower temperatures. This opens the door to the possibility of life thriving in places we'd consider utterly inhospitable. Picture a distant moon with oceans of liquid ammonia, teeming with exotic organisms that have evolved to harness its unique properties. Science fiction has long explored these ideas. Think of the silicon-based Horta from Star Trek or the ammonia-breathing creatures in Arthur C. Clarke's stories. These imaginative depictions challenge us to expand our understanding of what life could look like. This concept doesn't just stretch our imagination, it fundamentally changes how we define habitability. If life isn't limited to carbon and water, the universe becomes a much more interesting place. Planets and moons we once dismissed as barren might actually harbor life in forms we've yet to imagine. It's a reminder that the universe is full of surprises, and our search for life might just be beginning. So the next time you look up at the stars, ask yourself, what if life out there isn't just different in appearance? What if it's built on a completely different foundation? It's a question that has puzzled scientists and dreamers alike. If the universe is so vast, why haven't we heard anything from anyone out there? This is known as the Fermi Paradox, or more poetically, the Great Silence. For decades, we've been scanning the skies with powerful radio telescopes, listening intently for any sign of intelligent life, but the silence is profound. Does this mean we're alone, or could it mean we're simply not listening the right way? One theory suggests that advanced civilizations might have moved beyond the kind of communication we're actively searching for. Think about it. 100 years ago, we were sending radio waves into the cosmos, but today, our technology is evolving rapidly. Fiber optics, lasers, quantum communication. These are the tools we're turning to, and they're far more efficient than old-fashioned radio. If alien civilizations are similarly advanced, they might be using methods we can't even comprehend yet. Imagine trying to decode a message written in a language you've never heard of, using a technology you've never seen. Another possibility is that we're not looking in the right places or at the right times. The universe is unimaginably vast, and even our most powerful telescopes can only cover a tiny fraction of it. What if signals are being sent, but they're passing us by unnoticed? Or what if they're so faint, so distant that our technology simply can't pick them up? It's like trying to hear a whisper in a hurricane. Then there's the idea that maybe advanced civilizations are intentionally avoiding contact. Perhaps they've observed us and decided we're not ready, or worse, that we're too dangerous. It's a chilling thought, but one that raises important questions about how we present ourselves as a species. Are we sending the right message to the cosmos, or are we broadcasting chaos? The Great Silence is a humbling reminder of how much we still have to learn. Our technology is incredible, but it's also limited. We're like children standing on the shore of an endless ocean, barely dipping our toes into the water. What lies beneath the surface? What are we missing? The answer might be out there, waiting for us to find it, or perhaps waiting for us to evolve enough to finally understand. What if the discovery of alien life didn't just challenge our scientific understanding, but also shook the very foundations of what we believe about our place in the universe? Throughout history, religion and philosophy have guided how we make sense of existence, purpose, and the cosmos. But imagine for a moment that we're not alone. How would that revelation reshape these age-old frameworks? Think about it. Many religions are rooted in narratives about humanity's unique connection to the divine. What happens to those beliefs when we encounter intelligent beings who might also claim a spiritual or cosmic significance? The Vatican, for instance, has openly expressed curiosity about extraterrestrial life, with astronomers like Brother Guy Consolmagno suggesting that aliens could still be part of God's creation. This openness hints at a willingness to adapt, but it also raises questions about potential conflicts. Could some faiths struggle to reconcile the existence of alien life with their core doctrines? On the other hand, this discovery might spark a new era of philosophical enlightenment, pushing us to rethink concepts like morality, consciousness, and our role in a much vaster universe. It's not just about whether aliens exist, it's about what their existence means for the stories we've told ourselves for centuries. So, how would you personally reconcile the idea of extraterrestrial life with your own beliefs? Would it deepen your sense of wonder or challenge everything you thought you knew? The answers might just redefine what it means to be human. The search for alien life is about to enter a thrilling new era, thanks to groundbreaking missions and technologies on the horizon. Take the James Webb Space Telescope, for instance. This marvel of engineering isn't just another telescope, it's a game changer. With its ability to peer deeper into the cosmos than ever before, it can analyze the atmospheres of distant exoplanets, searching for telltale signs of life like oxygen, methane, or even water vapor. Imagine the implications if it detects a planet with conditions eerily similar to Earth's. The possibilities are staggering, but that's just the beginning. Consider the ambitious plans for interstellar probes like Project Starshot. This visionary initiative aims to send tiny, light-powered spacecraft to our nearest star system, Alpha Centauri, within a single human lifetime. These probes could gather data from planets that might host life, sending back information that could reshape our understanding of the universe. It's a bold leap forward, one that could bring us face to face with the answers we've been seeking for centuries. What's equally exciting is the spirit of international collaboration driving these efforts. Space agencies from around the globe, NASA, ESA, JAXA, and more, are pooling their expertise and resources to tackle these monumental challenges. Together, they're proving that the search for alien life isn't just a scientific endeavor, it's a unifying mission for all of humanity. The next decade promises to be one of the most transformative periods in the history of space exploration. With cutting-edge technology and unprecedented cooperation, we're on the brink of discoveries that could change everything. The question isn't just, are we alone? It's, how soon will we find out? The future is closer than we think, and it's brimming with possibilities. As we ponder the existence of extraterrestrial life, one question looms larger than most: what happens if we make contact? The ethical implications of reaching out to another civilization are profound and far-reaching. Imagine the impact of introducing our culture, technology, or even diseases to a species that might not be prepared for such an encounter. The potential for cultural contamination is immense, and the consequences could be irreversible. On the flip side, what if their intentions aren't peaceful? History has shown us that misunderstandings between civilizations can lead to conflict, and in this case, the stakes would be unimaginably high. This isn't just a hypothetical scenario, it's a real dilemma scientists and ethicists are grappling with today. The idea of establishing a protocol for first contact has gained traction in recent years. Organizations like the SETI Institute have even drafted guidelines to ensure that any communication with an extraterrestrial civilization is handled with care and respect. These protocols emphasize the importance of mutual understanding, transparency, and a commitment to avoiding harm. But who gets to decide what's ethical in such a groundbreaking moment? And how do we balance curiosity with caution? As part of a cosmic community, we have a responsibility not just to ourselves but to other potential life forms. This raises questions about our role in the universe. Are we ready to take on the role of ambassadors for humanity, or could our actions inadvertently cause harm on a cosmic scale? These aren't easy questions to answer, but they're essential to consider as we continue to search for signs of life beyond our planet. The ethical implications of contact remind us that the universe isn't just a place to explore. It's a space where we must tread thoughtfully with humility and respect. As we arrive at the final fact in our journey through the mysteries of alien life, let's take a moment to step back and see the bigger picture. The search for extraterrestrial intelligence isn't just about finding life beyond Earth. It's about understanding who we are and where we fit in the grand tapestry of the universe. This quest transcends borders, cultures, and even generations. It's a shared human endeavor that reminds us of our collective curiosity and our innate drive to explore the unknown. Think about it. Every time we point a telescope at a distant star or send a probe into the depths of space, we're asking questions that have echoed through history. From ancient civilizations gazing at the night sky to modern scientists analyzing data from distant exoplanets, humanity has always wondered if we're alone. This universal curiosity connects us, bridging gaps between people and cultures. It's a reminder that, despite our differences, we're all part of something much larger than ourselves. The pursuit of alien life also challenges us to think beyond our own existence. It forces us to confront questions about the nature of life, the fragility of our planet, and the potential for civilizations far beyond our own. What does it mean if we're not alone? What does it mean if we are? These questions don't just expand our scientific understanding, they invite us to reflect on our place in the cosmos and the responsibilities that come with it. Perhaps the most inspiring part of this search is the sense of wonder it sparks. The universe is vast, mysterious, and filled with possibilities we've only begun to imagine. Whether or not we ever find definitive proof of alien life, the journey itself is a testament to human creativity, resilience, and the unquenchable desire to explore. So, as we look to the stars, let's carry that sense of wonder with us. Let it remind us to stay curious, to keep asking questions, and to keep dreaming big. Because in the end, the search for alien life isn't just about discovering others, it's about discovering ourselves. So, what have we learned from these 20 fascinating facts about alien life? From the mysterious signals captured by radio telescopes to the tantalizing possibilities of microbial life on Mars, the evidence is as diverse as it is compelling. We've explored theories that range from ancient astronaut hypotheses to the mathematical likelihood of intelligent civilizations scattered across the cosmos. Each fact has peeled back another layer of the mystery, reminding us just how much we still have to discover. This journey raises profound questions, not just about whether we're alone, but about what it means to be intelligent, to exist, and to share this vast universe with others. Are we the exception, or are we just one thread in a cosmic tapestry of life? These questions don't just challenge our understanding of science, they challenge our understanding of ourselves. But here's the thing, the search for answers is far from over. Every discovery, every signal, every new theory brings us closer to uncovering the truth. And that's why this topic is so exciting. It's a reminder that the universe is full of possibilities waiting to be explored. So keep looking up, keep asking questions. Keep wondering about what might be out there, because while the universe is vast and the mysteries are many, one thing is certain: the search for life is just beginning. And who knows, the answers might be closer than we think. The stars are calling, will we